Power and Energy. November 16, 2020. Wärtsilä supplies energy storage system to Singapore. Triton Knowle-Mark's project firsts as blades arrive at Seaton Port. Sunstyle plant demonstrates 1 GW supply ambition by 2025. Vattenfall to start construction of Klaverspor wind farm. Advantages of graphene for photovoltaics.
The 2.4 MW energy storage system supplied by the technology group Wärtsilä for Sunstyle Energy Ventures of Singapore under an engineering, procurement and construction contract has been installed. The energy storage system facility is a testbed supported by Singapore's Energy Market Authority and SP Group, a leading energy utilities company in Asia Pacific, and it represents an important milestone in Singapore's energy transition towards a low-carbon energy future. This is the first utility-scale energy storage system in Singapore. It features Wärtsilä's GEMS advanced energy management platform, as well as the company's GridSolve Max solution, a standardized energy storage technology designed for safety with core storage hardware assets, including batteries and inverters. The energy storage system will participate in the wholesale electricity market to provide services necessary to mitigate intermittency caused by solar, as well as reduce peak demand. The utility-scale energy storage system will also provide insights into energy storage system performance under Singapore's hot and humid environment and will aid in establishing technical guidelines for such deployments. Singapore targets to have at least 2 GW of solar deployment by 2030, and an energy storage deployment of 200 MW beyond 2025.
Triton Knowle is marking a series of project firsts as turbine blades destined to be installed at the 857 MW offshore wind farm arrive at its chosen construction port in Teesside. The first 15 turbine blades to arrive at the port were manufactured by MHI Vestas at its Isle of Wight UK facility and finished at its Foley plant across the Solent. Seaton Port, near Hartlepool, is receiving offshore wind turbine components for the first time in its history, after a combined multi-million-pound investment has helped transform the port into a specialist assembly and construction facility for use on the project by turbine supplier MHI Vestas Offshore Wind. MHI Vestas recently moved on to the 140,000 square meter Seaton Port, where it is establishing a full turbine logistics and pre-assembly hub for the RWE-managed joint venture project. Triton Knowle, which is being constructed by RWE, will install and operate 90 MHI Vestas V164 9.5 MW turbines, each stretching 164 meters tip to tip, and capable of powering a typical home for up to 29 hours with a single rotation of its 80-meter-long blades. The state-of-the-art Triton Knowle offshore wind farm will have a maximum installed capacity of 857 megawatts and, once fully operational, will be one of the 3 largest offshore wind farms in the world, capable of powering the equivalent of over 800,000 UK homes. The project is located over 32 kilometers off the Lincolnshire coast, with a turbine array that covers an area of 145 square kilometers, bigger than the city of Manchester. It is jointly owned by RWE, J-Power and Kansai Electric Power, with RWE managing the wind farm's construction and long-term operation and maintenance works, on behalf of its project partners.
The Sunstyle production plant was officially recently launched, in the presence of the French Minister of Ecological Transition Barbara Pompili. The production plant is aiming to supply 1 GW of solar tiles by 2025. The Sunstyle tile is a textured glass sheet protecting solar cells. It thus transforms sunlight into clean and unlimited electrical energy. Its production capacity is 115 watt peak for a black tile and 85 watt peak for a colored one. In addition, Sunstyle was distinguished among the first solutions labeled by the Solar Impulse Foundation as an innovative and viable technology to protect the environment. A watertight and aesthetic solar tile that meets the highest standards as well as ensuring a roof's traditional functions, such as being waterproof and allowing rain to naturally run off it. Sunstyle technology combines the production of solar electricity and contemporary aesthetics respecting regional traditions. This solution aims to comply with the stringent requirements of Architecte des Bâtiments de France, who ensure that historic buildings and areas are not spoiled, notably in protected areas. Lastly, this technology has been certified by the TÜV Rheinland and approved by the Scientific and Technical Center for Building, i.e. the most stringent French and international specifications in terms of construction and frame elements. It is thus ready to be deployed worldwide. The Sunstyle solar tile combines two functions in one product: water tightness and energy production. The tile's size of 870 mm by 870 mm makes them simple and quick to install. They require almost no maintenance and are an extremely long-lasting construction element. As such, they represent long-term savings for the building, as it is estimated that the total cost of the equipment is amortized after 10 to 14 years.
This autumn, Vattenfall will start the construction of Kliverspoor wind farm in the province of Noord-Brabant in the Netherlands next to the A16 motorway. The project involves an investment of €45 million. 25% of this amount will come from the Brabantse Ontwikkelingsmaatschappij. Kliverspoor wind farm is one of the 5 wind farms being built along the A16 motorway. An appeal against the construction of the wind turbines along the A16 was lodged with the Council of State. In July 2020, the Council of State declared the appeals, those relevant to Kliverspoor, to be unfounded. However, the Council of State ruled that the province of Noord-Brabant still needs to revise a number of elements in the A16 wind energy adaptation plan. This includes adjustments for other wind farms along the A16. The decision of the Council of State has no consequences for the construction of Kliverspoor. That is why Vattenfall has decided not to wait for the final decision of the Council of State before taking an investment decision. The 6 wind turbines of Kliverspoor will be located in the polder of Ben en Moerdijk along the A16. In November 2020, Vattenfall will start the first works on site, preparations for the construction of a road towards the new railroad crossing. Construction company Heijmans will carry out all civil engineering, such as the construction of roads, cranes, cables and foundations for the wind farm. Wind turbine manufacturer Nordex Group will supply and install the 6 turbines of type N149/5X with a height of 135 meters. Kliverspoor will supply the first green electricity in the second half of 2022. The expected installed capacity of the wind farm is 34.2 megawatts. The amount of electricity produced annually by these 6 wind turbines will be supplied to companies and customers and could be compared with the average annual consumption of approximately 30,000 Dutch households.
Enel Green Power is taking part in the EU-backed GRAPES project to research new applications for a very versatile material called graphene, which boosts the efficiency of solar cells. The alliance between academic and industrial research is fundamental to accelerating the energy transition. This is why Enel is taking part in international projects focused on finding increasingly efficient technological solutions that will exploit renewable sources. One example is the Core 3 Spearhead Project GRAPES, a European Union initiative that is part of the Graphene Flagship, a major project researching the use of graphene in which the EU is investing €1 billion. Graphene, which comprises a single layer of carbon atoms, is a very versatile material with applications in a wide variety of fields such as electronics, sensors, aeronautics and, of course, photovoltaics. The research group led by FOTI is working specifically on using graphene, which has the same theoretical strength as a diamond and the flexibility of plastic, to integrate silicon and perovskite cells. The technology required to exceed these limits is a tandem or multi-junction cell in which 2 cells are overlapped with each one converting a different part of the solar spectrum into energy. The silicon cell converts the red end of the light spectrum into energy while the perovskite absorbs the blue and green part, thereby boosting efficiency. Graphene can optimize performances and reduce costs. Indeed, researchers are attempting to use it to replace all or part of the more expensive silver used in conductive adhesive. According to some studies, placing a layer of graphene between the silicon and perovskite cells may be the ideal way to produce a significant improvement in efficiency and reliability.